Alright guys, we're talking about the real number system, so let's get into it. I'm going to try to fix this so we can see a little bit better. Okay, this is the page we're starting on. Can everybody see that okay? I know it's kind of bright. Give me just a second. Alright, it looks a little bit better. So, the real number system is how we categorize and arrange numbers in my class, SRAB, Foundations, and Algebra 1. This should be the only number system that we talk about within this class. Anything that's pertaining to complex numbers happens later on, okay? So, every number we talk about will be real. But real is then broken down into two sections. So, it's either rational or it's irrational. It can't be both. It's either this or it's that, okay? Both of these are real, but it then goes into, is it this or is it that? For irrational, those are decimals that never end or repeat. So that's important to make note of. That's a highlight thing. So it's non-repeating, non-terminating. Examples are, we most commonly see pi the most. Pi is equivalent to 3.14159265, and it just continues on. If you see those three dots, that means it goes on forever without stopping. Does that make sense? Another common one is the square root of 2. That is written as 1.41421356, and it goes on forever. We call this a non-perfect square. Other ones are things similar to that of just decimals of 0.1, 2, 3, 4, 5, 6, 7, 8, 9 onward. And they can also be negative. So an example I'll give is negative 8.5936428249, and that also goes on forever. Everybody good there? Not with the writing. I mean with what I just explained. If you're writing, you're fine. Keep writing. Take your time. All right, everybody good? Yes, no? Okay. Looking at rational, these are fractions that do end or terminate, so they do that. There's multiple examples of that. We have 0 is rational, -8 is rational, and 4 are rational. Why are all three of these whole numbers rational? How can they be written as a fraction? By putting it over 1. That's what makes it true. So the same thing is, what about 2/3? That's a fraction. We have 0.57. Bless you. That's a decimal that terminates. Rational numbers can also be negative, so we have negative 0.3 repeating. And then we can have one that goes on forever. So we have 4.5959, and it just keeps going. The three dots are at the end. Everybody good? Keep writing. You're okay. Is everybody good for me to continue on? Yes, ma'am. You're good. Just let me know when y'all are good for me to go. So Jordan, you're good? Aaliyah, you still writing? Which part you writing? You good? Okay. Just make sure y'all vocalize it to me. That way I know, okay? Because when I'm looking down, I can't see head nods and head shakes. That's the hardest part, okay? So, looking at integers, they are one step below rational, which means, what am I taking away from rational to integer? Do you remember? What can integers not be? Decimals or fractions. So, I can start with anything. I'm going to start with 3 dots because this is a number line that continues forever in both directions. And I have -3, -2, -1, 0, 1, 2, 3, and this goes on forever as well. It is a number line. Integers are all whole numbers and their opposites. So, if you have 1, 2, and 3, you also have -1, -2, -3. If you have 56, you also have -56. It's a number line that we typically write out all the time. Any questions there? Everybody good? Let's look at whole numbers. Whole numbers start where? With what number? 0. And then it's all numbers that follow behind it. So what comes after 0? Then, and then so on and so forth, right? So from integers to whole numbers, I took away what? All the negatives. So which means I only have 0 and all the positive whole numbers. Does that make sense? So, looking at natural numbers. Natural numbers. What do natural numbers start with? 1. Because they're numbers that you can do what? Count. So it starts off with 1, 2, 3, 4, and onward. These are our counting numbers. Now, what they're saying with this arrow is that we typically start from the lowest and we add something on each layer. Does that make sense? So the direction matters, okay? So all natural numbers are whole numbers. All whole numbers are integers. And all integers, whole numbers, and natural numbers are rational. Does that make sense? So I'll say that again. All natural numbers are whole numbers. All whole numbers are integers. And since all of these fall into integers, all 3 of them are rational. But if you were to go in the opposite direction, not all rational numbers are integers because these have decimals and fractions and these do not. Not all integers are whole numbers because integers have negatives and whole numbers do not. And all whole numbers are not natural because they have 0 and natural numbers do not. Does that make sense? Everybody good? Awesome. So what I'm going to have you write right here is direction matters. Everybody good right here? So we're going to use this to help us with example number 1 down here, okay? So the directions are, because they're not listed here, I'm going to have you write the directions in. You're going to mark all categories, each number classifies in. That's the directions. Mark all categories each number classifies in. Yes, sir. Oh, you want to answer the first one? Okay, great. Awesome. Where does it all fall? Real. Because every number we talk about is going to be real, right? Right. What's next? Rational. Do you think it goes anywhere else? Because if it's rational, it can't be irrational, right? So that automatically knocks that one out. Can integers be fractions? Can whole numbers be fractions? Can natural numbers be fractions? So Kingston's right. Those two are the only one that needs to be marked. Does that make sense? Good job. Anyone want to do the second one? Other than Kingston? You got to give other people chances, right? Anyone want to try the second one? Yes, ma'am. So you said real and rational. My question here is, can this be simplified? How did you get a whole number? Dividing and seeing if it simplifies. So what's negative 27 divided by 9? Negative 3. So this is the one you actually should be looking at, right? But she's still correct on these two. But what else can it be, Annabelle? An integer, because it's a negative whole number. You always simplify to check every time. Because 2/3, if you were to type that in, it's 0.6 repeating. So we already know that that's not going to simplify further. So it would only have to be rational. But in ones like this, that you see a bigger number, smaller number, that kind of thing, try to see if you can simplify by typing it in. Everybody following? Always check your fractions, okay? Great job. Yes. What did you say? One more time? What does irrational mean? What was it? No, I know, but you're the one that wanted to answer this one, right? I heard Kinley over there. She has the idea because she read that direction up there, right? What does it say next to irrational? It's what? Is this ending anywhere? Is it repeating anywhere? So are you right? There you go. The reason why I asked you a question is because you asked me a question. When you're answering a question, don't ask me. Tell me. You're going to hear me say it with your chest a lot. And it's not to insult you. It's to make you confident. Okay? So don't say, is it this? I'm going to say, are you asking me or are you telling me? Okay? Tell me. Who wants to help me with the fourth one? Kingston, give somebody else a try. Come on, y'all. Somebody else try it. So I heard from Annabelle, I heard from Zatarian, and I heard from Kingston. All right, Kinley, what you think? Real and rational. Because mixed numbers automatically are what? Starts with F. You got it. Mixed numbers are automatically what? Starts with an F. FR. Fractions. So, you had that right immediately. Sir. Give other people a chance. Yes, sir.
Won't it be a whole number too?
No. Why is that not a whole number?
There's a fraction.
Because there's a fraction. Whole numbers can't have fractions attached. That's what I'm trying to tell you. This is 4.3 repeating.
4 times 3 plus 1.
Baby, that's still going to be a fraction because it's going to be 13 over 3. That's what I'm trying to tell you. It's 4.3 repeating. You have great questions. Keep asking those questions, okay? Who wants to help me with the 5th one? Someone I haven't heard from yet. Come on, other people. Let's go. Y'all don't want me to start popcorning, y'all. Let's go, Kylan. You got it. You're absolutely correct, but don't ask me. Tell me, right? Confidence. You're saying, Miss Lipsey, say it to me.
Is real and irrational.
Absolutely. Because we just said the square root of 2 is irrational at the top, right? It's the most common one we use, and they can also be negative. So I agree completely. And if it's irrational, we ain't got to check nothing else. That's all it is. Good job. What about the 6th one? Who wants to help me with that one? Who I haven't heard from yet, small children? What you think, Brandon? You got this.
Real
Real.
and irrational.
What does irrational mean? Read the definition for me up at the top.
Decimals that never end or repeat.
So, what does that line mean up there on top of the 6? Over the 6. You see where it says 4.56 and there's a line over the 6?
I was doing the one that was below that.
You're okay.
Real and rational.
Because what does that line mean? The 6 is going to do what? Repeat.
Oh, yeah.
Thank you for helping. Repeat. Good job. Can it be anything else?
No.
Because it's a what? Starts with a D. Kingston just helped you.
Decimal.
It's a decimal. Does that make sense? The rest of those have to be whole numbers, okay? And if you already said it's rational, it automatically can't be irrational, okay? So you got it. It's all about trying, right? All right, who wants to help me with the next one? Kingston, dadgummit, let somebody else try. Gavin, try this one.
Real.
Real. Mm-hmm.
Irrational.
Did we simplify it? Let's type this in. Y'all type it in along with Gavin, but me and Gavin are going to do this one. So the way we type it in, remember, we hit second x squared, and then we type in 4 divided by 49. I put mine in parentheses because it is a fraction, okay? So try to type it in this way similarly, okay? What'd you end up getting?
4.2857.
Absolutely. Gavin, can you hit math 1 enter on your calculator, please?
27.
Is that a fraction? So which one do you think it is? There you go. Can it be anything else, Gavin? No, because all the rest of them got to be whole, right? We got it. You was there. We gonna make it work, okay? So, is everybody okay with how to type this in? Always type it in. Yes, ma'am. Math 1 enter. Did you type this in and get this decimal? So that's the issue. You got to type in the first part, baby. If the answer doesn't pop up next to it, it's not going to. So try it again for me real quick. Everybody else, pause for just a second. We're trying to make sure our classmate is caught up with us. But those who know I have not heard from them, be prepared. I'm going to popcorn you next. There you go. All right. Someone who I haven't heard before now. Now I know I ain't heard from Ian. I ain't heard from Denver. I ain't heard from Aaliyah. I ain't heard from Jordan. I ain't heard from Stavon over there.
What about me?
I done heard from y'all.
Come on, let me do it.
Ian, you want to try this one with me? What do you think? You said real and rational. Did you simplify this to see what you got? What'd you get? 4/9. Perfect. Can it be anything else, Ian? You absolutely right. Because doesn't those have to be real whole over there? So there we go. You see how quick that was? You go, Ian. Proud of you. All right. My 4 other people. You got this last one, Aaliyah? Okay, tell me what you got. Are we missing something? What are we missing? Natural or what numbers? Natural numbers are what kind of numbers?
Oh, counting numbers.
Absolutely, because what's right there in the middle of that -1 and 1? And what did you get when you did 0 divided by 6? Let me tell you a trick. It can't be whole without being an integer in that same spot. So if you're working from this way going down, if you mark integer and it's 0, it also is a whole number. Does that make sense? That direction matters. Any questions? Great job. Remember, calculator, simplify. Always check, okay? If it doesn't give you a number, always check. Any questions? Y'all doing a great job. Let's look on. Example number 2. It says, give an example of each. A rational number that is not a whole number. Give me a rational number that is not a whole number. Yes? Yes? 0.6 repeating. Give me some that aren't on your pages, okay? I need at least 2 more examples. So, no, Kingston, give somebody else a try, okay? We gonna come back to you, see how I cycle back to you. Give somebody else a try. Rational number that's not whole. What do y'all think? Kenley, what you got? 1/3. That works. Yes, sir. No, wait. I just heard from you. Stop confusing my brain. Annabelle, what'd you got? Because I saw your hand up when Kenley put hers up. 1/7. Can I make yours negative? There we go. So we have 0.6 repeating, 1/3, and 1/7. My question to you is, could -8 work in this case? Because why is -8 not whole?
Because holes on the positive.
Wholes are only positive. I'm going to add that -8 on there, and that's Miss Lipsey's contribution. Okay?
Never mind.
What? What were we about to say?
No, I was going to say, that number be like that, only is negative.
Because whole numbers can never be negative. Kingston said it best. They can only be positive numbers and 0. So if you put a -8 there, it said, what's rational? That could be a fraction. By putting it over what number? 1. You see how it still works? There you go. An integer that is not rational. An integer that is not rational. Do you think that's possible? Because don't all integers fall into rational numbers? So that's not possible. Because all integers are rational. Because we can write them as fractions by putting them over what? There you go. You see why it's important to know those rules? Having classification in number sense is great. They are great tools. A real number that is not rational. The square root of 2. Bless you, sir. Give me something else that's not listed on your paper. Stevan, give me an example. A real number that's not rational.
It's not on paper.
Choose one that's not on the paper.
I can't think right now.
Try something. Go and look at the descriptions. There you go. It's literally a page flip away. I see everybody's hands that I see. I got you. You're overthinking it, sir. What is the opposite of rational? What's written to the word next to the word irrational? What's the definition?
Decimals that never end or repeat.
So give me a decimal that never ends and does not repeat. Don't overthink it. Just give me a decimal that doesn't end or not repeat.
can think of it, no?
Yes, and it's not that hard. You're making this way complicated.
I know.
3.14.
What was it?
3.14.
No. Because pi's already on there. We already know that. You're overthinking it. Literally, it does not repeat and it does not terminate. You see how everybody's coming up with one because they're not overthinking it.
3.567.
What was it?
1.3567.
Is that repeat anywhere?
He just said, keep
Savon, does it go on forever? Because I put 3 dots at the end, didn't I? So you're fine. You see how that just worked? Don't make it complicated, baby. Aaliyah, what you got? The square root of 5. Because ain't that a non-perfect square? Come on now. You better say that over there. Yes, ma'am. Annabelle.
Is Planck's constant a real number?
Planck's constant is a real number, actually, but it is an irrational number, just like pi is, just like e is. So the fact that you know that, ma'am, you are going some places, okay? Because Planck's constant is used typically in like physics, so you don't really see it here unless you're in a physics course. That's a science course that's math based. Yep. See, look at that.
you see me?
Girl, you making more and more sense of why you want to go to where you want to go to. I love to see it. Let me give Stevan something else he can look at. So, pause just a second. When you're doing things that do not repeat and don't terminate, Stevan, you're looking at a pattern, okay? So, it's just as easy as saying negative 0.20, 220, 2220. What's going to follow after the 0?
2, 2, 2.
Because isn't that just a pattern that I'm making? Is there anything repeating? No, because repetition means it has to be the same thing over and over and over again. I'm adding a 2 every time. Now, don't overthink that part of it, okay? Any questions there? D, a number that is not rational.
Oh,
Sir,
5.
5. A number that is not rational. Somebody else tell me something. Denver, give me one. A number that is not rational. Don't overthink it. Sorry, a number that's not irrational. Sorry, Kyle, that was me. A number that is not irrational. So you're looking at everything on the left side of what we just wrote. Give her a second. Try. Throw a number at me and I'll tell you yes or no. Don't overthink it. A number that is not irrational. So what's the opposite of irrational? Look on the opposite side of your paper, baby. So if you flip this over, you're either this or you're that. It says it's not this, so it has to be what? So it could be anything on this side, correct? Give me a number. You got it.
He said something there. Oh, that's great.
Timber, just say a number, baby. You got it. 0. That works.
Actually, alright, on shoulders.
Zetarian, yes.
6. That works.
6 works, but I'm not writing it because you can do better than that. Jordan, give me a number that's not rational. Well, not irrational. Make it spicy. Make it more exciting than 5 and 0. Come on, you got it. Which means it could be anything on the left-hand side underneath rational. Your classmates are getting an arm workout. They really want to tell me these numbers. I see y'all. Don't worry. I see. Come on, Jordan. Give me one. It could be anything on the left side. So it can be rational. It can be an integer. It can be a whole number, or it could be natural. But I already have a natural and a whole number, so I don't need all that. Give me something else. Absolutely, as long as it's perfect. Come on, Jordan, you got it.
I don't know.
Baby, try. That's all I ask you to do. Just give me a number. I'll tell you yes or no.
Maybe one this time.
On the left.
On top of that.
So which means it could be anything on the left-hand side because it says not irrational. So it has to be rational or anything underneath there. But I already have a natural and a whole number. I don't need any more of those. So I'm looking for a rational number or an integer. I'm going to give you two examples from two of your classmates, and then I'm going to come back to you so you can give me one. Aaliyah, what'd you have? The square root of 4, because that simplifies into... Thank you. Colin, what'd you have? 1 over 2, because ain't that rational? Come on now. Jordan, what you got? Huh? Baby, try one. Look at the examples your classmates just gave.
-81. So what about the square root of
You got it, Jordan. We gonna get it. Look at all the examples your classmates gave on this line. Look up. You have so many opportunities there. Just throw out a number. You got this. You're just looking at line D. So you're just looking at this one. We don't care about the ones up top. Just look at these examples. You got it. Throw out a number. Make it better than that. How can you make it better? What could integers be? Flip your page over, look at integers. What could integers be? What makes them different than whole numbers? They can be what? So how can you make 2 better? Thank you. Guys, I'm going to make a brief intermission here. Trying your best is all I ask you to do, right? This is a big key sign if I can tell that you know what you're doing and know what you're not doing. We're just classifying numbers. So if you're struggling with that, when I just went through the whole lesson of how to do it, but then you were sleeping, had your head down, and you weren't participating, you see how it shows when we're trying to do classwork participation and discussion? That's not to call anybody out. That's to hold you accountable. Because you're going to have to do this at a quicker scale next year when you're doing Algebra 1 for a semester, right? So when they go over it and they say the real number system, we're getting it one and done in one day. Your Algebra 1 review quiz, like your actual pre-algebra quiz, is going to happen by Friday of the same week you just learned this. You got to know what you're doing, okay? Hold yourself accountable. And this is why we don't sleep in class. Yes, sir. Next one, a rational number that is not an integer. Yes, Kingston.
40?
Huh? 40. Are you sure? Isn't 40 an integer? How can I change 40 to make it not an integer? Huh? Nope. What do you think, Annabelle? Make it a decimal. Add more to it. So what do you want to put? Baby, leave the 40. What are you... Baby, that don't do anything. What am I adding afterwards? Not quite. I need a little bit more than that, because it does 40 with dot 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 at the end doesn't mean anything. Does that make sense? When you're creating a decimal, you need a decimal and something afterwards. Does that make sense? So what can I add after 40? Yes, ma'am. 0.26. That is a terminating decimal, which makes it rational. But it's a decimal, which means it's not an integer. You see, you got to know the rules. You got to know the rules. Good job, Aaliyah and Annabelle, for that catch. Just make it a decimal. Give me another example. Let's see if you can redeem yourself. 2.6. I'm going to put repeating there. Yes, ma'am. 1/7. I'm going to make yours negative. That way we can see that that's still true. Yes. It's just like this 2.6. That's the only reason why I'm not going to write it. It's the exact same. But yes, you can also put that one. Any questions on this example list up here? Everybody good? We gonna make it. Example 3. Determine if the following are always true, sometimes true, or never true. Remember, does direction matter? Yes. A. Whole numbers are real numbers. Is that always true, sometimes true, or never true?
Always true.
How do you know it's always true?
There's a whole number. Because every number we talk about is real.
Every number we talk about is going to be real. The direction matters. So, this is always true. Any questions there? Rational numbers are integers. Always, sometimes, or never.
Sometimes.
Kinley, what do you think? Why do you think it's sometimes? Not the negative aspect. What can rational numbers be that integers can't be? Annabelle, help her out. Decimals and fractions. But integers always have to be what kind of number? Whole. So that is correct. Sometimes true. So let's say this is our example. 5 is an integer, right? But 5/2 is not an integer. Because one is whole and the other one is a decimal fraction. Any questions there? Everybody good? Okay. Integers are rational numbers. Integers are rational numbers. Kingston, get somebody else to try, okay? Who wants to try to help me with this one? I've heard from Kingston, I've heard from Kinley and Annabelle. Aaliyah, what do you think? Why do you think sometimes? Let me follow up with that one with a better question. Does direction matter in this case? Are you starting with the smallest and going to the largest? Or are you starting with the largest and going to the smallest? What did you start off with? What came first? So you started with the smallest of the two, and it's going to the... Do you need integers in order to make rational numbers? Think about it. It's the complete opposite of this one. Do you see that? So where this is sometimes true because fractions exist in rationals but not in integers, all integers exist in rationals. So what is the answer instead? There you go. Okay. Rational numbers are irrational numbers. Yes, Kylan? Why do you think it's never? They're two separate kinds. Either you're this one or you're that one. You can't be both. Absolutely. Believe it or not, D catches people up more than the other ones. Not sure why, but we're going to figure it out one of these days. And finally, natural numbers are integers. Natural numbers are integers. Who wants to help me with this one? Kingston, give people a chance. I love your participation heart, but baby, you are maxing out participation, and I love it. But let somebody else try. So I've heard from Annabelle, Kinley, Aaliyah, and Kingston, and Kylan. So who wants to help me with this one that I haven't said their name for? So Terry, you want to try this one?
Not this one. I'm not sure about this one.
Well, tell me what you think. What are natural numbers? Numbers you can what? You can count, right? And what are integers? But they have what characteristics? What makes integers different than natural numbers? They can be... They can be what? Negative or positive, but they're all whole, correct? So, are natural numbers the smaller or the larger one of the two? Are natural numbers the smaller group or the larger group between integers and int? Think about it. Look on your actual diagram. Which one's smaller? Because does it have as many numbers as integers? No. So, do we have all the natural numbers in the integer place? Because did we see 1 in there? Did we see 2 in there? And you tell me it keeps going on forever, right? So are all the positive numbers inside of the integer one? So, is this always, sometimes, or never true? Always. The direction matters. Any questions there? Now, let's look at example number 4, okay? These involve a little bit more thought, okay? It says determine if they are always true, sometimes true, or never true. The product of a rational number and an irrational number is irrational. What does product mean? Multiplication. So I'm multiplying what kind of number? To a irrational number, okay? So, give me an example of a rational number. 6. Give me an example of an irrational number. Irrational. Pi. So if I were to say 6 times pi, that would give me 6 pi, which is irrational, correct? That's the I means. That's irrational. But what if I said 0 times pi? It would equal 0. Is 0 rational or irrational? So, sorry, rational is done with a Q, not an R. That double-sided R means real. My brain was somewhere else. Disregard me in my old age. My brain is going. So, Q stands for quotient when you're talking about rational numbers. So, is this always, sometimes, or never true? Sometimes, because you gave me an example where it is true. You gave me an example where it's not true. So, this is sometimes true. When you see examples like example number 4, it's better to write out the work to understand what's going on. Okay? So, let's look at B. The sum of an irrational number and a rational number is rational. What do you think, Kyle? Can you give me an example? So what does sum mean? What does sum mean? Like S-U-M. Not multiply. Plus. So, give me an example of an irrational number. It could be any of the ones that we used in previous examples.
2 squared.
So the square root of 2, right? Give me an example of a rational number. That works. So let's type this in our calculator. So I have the square root of 2. Make sure you hit the right arrow to get out of the square root, plus 5. So type in the square root of 2 plus 5. What did you get when you hit enter?
6.4
So that's a decimal that neither terminates nor repeats. So is that rational or irrational? And never ends or repeats. It's irrational. So in this case, this is irrational as well, right? So I'm going to write 6.4142, and I'm going to write my 3 dots. That's irrational. But even if I switched that square root of 2 to 0, or switched it to another square root of 2, it will always yield an irrational number. Yes, ma'am.
Well, then what if you made it 7 and made it square root of 9?
What was it?
What if you changed the 5 to a 7 and made it the square root of 9?
So the square root of 7, and you said minus 9?
No, the square root of 2 plus 7.
Square root of 2 plus 7. Notice, we can't put it underneath there, because this has to be irrational on its own. What you're creating is not what they're asking for. Does that make sense? So you can't put 2 plus 7. It has to be an irrational number by itself. So which means fully simplified, it is irrational. So I can't put that underneath there because that wouldn't be a true statement. Because then that would make a rational number, which is getting this part, but then I also have to add it to an irrational number still. So it still wouldn't work. Sorry. It's irrational. This is never true. So make sure you write that down. We love it though. Too close to the bell, baby? You can go after announcements. Yes, sir. Hmm? You can't put it underneath there because it does not meet the criteria. One of them has to be irrational. Let me say that again. One of the numbers has to be irrational. So if you do the square root of 2 plus 7, that simplifies into 3. 3 is not irrational. That would be your rational number. So which means I still have to give you an irrational number. You're trying to cheat the system that you're not doing what they're asking you to do. Math has steps for a reason. But your reason makes sense, but all you did was give me a rational number. I need an irrational number still. Make sense? It's never true. And that's because it has to simplify to be irrational on its own. So the square root of 7, it's great. Not 7 plus 2. Because then you still have to give me one of those. Any questions there? Hopefully that makes better sense. Okay. Look at C. The difference of an integer and a natural number is a whole number. So what word is important here? Difference. The difference of an integer and a natural number is a whole number. So what does difference mean? So I need an integer. 2 minus, what is a natural number? So give me a number. 7, 1, that works. I'll use 1 for the next example, right? So what's 2 minus 7? Is negative 5 a whole number? Because it's what? So that's not whole. So you just gave me an example where it does not work. But there's 2 minus 1, correct? Which gets you? Isn't 1 a whole number? So is this sometimes, always, or never true? Sometimes. Because you just gave me the proof. You see where it's coming from now, Kingston? Annabelle, is that making more sense about how to pull the numbers? Okay. Any questions there? The product of 2 irrational numbers is rational. So, what word is important? Product. I need 2 irrational numbers, please. You can use ones that we previously used. Yes, ma'am. What was it? Yeah, irrational. try to keep it as clean as you can.
3.235.
Oh, try to keep it cleaner. How about we use some non-perfect squares for this one? So give me some non-perfect squares.
1.5.
Yep, so square root of 5. And how about we multiply that by the square root of 5 as well? Can you open the door for me? Anyone want anything off the snack cart? If you want something, Kinley, go, baby, because she'll go quick. You don't want anything? Okay, anybody want anything off snack cart? Everybody good? Type in the square root of 5 times the square root of 5. This is the last one I'm going to do with y'all. So you see how I typed in the square root of 5 times the square root of 5? You have to hit the right arrow to get out.
They all good?
Yeah, they're good.
They're good. Thank you, Ms. Wine.
What'd you get when you typed it in? Is that a whole number?
I pledge allegiance
Is that rational?
to the flag of the United States of America and to the republic for which it stands,
But is there an example I can use where it's going to give me an irrational one?
with liberty
What
and
about
justice
pi
for
times
all.
pi?
You may be seated.
That's going to be irrational automatically, right? So is that sometimes, always, or never?
The boys and girls
Sometimes.
soccer team will be tomorrow
So
at
pi
the school.
times
Meet
pi
the football field
will always be, because it's going to just be pi squared, which is irrational.
Running shoes.
So this is sometimes.
Students and student athletes, FCA, the Fellowship of Christian Athletes.
I want y'all to try
FCA
E
leaders
this
for the
evening and tell me what your
24-25
answer is
season. If you're
tomorrow,
interested in
okay?
becoming an FCA leader,
Try
or you
E
have
this
already
evening,
been one,
that's it,
please head to
and
the
come in
detail
tomorrow with
room
your
at
answer.
this time for more information. Mr. Kelly
So
is
get packed
located
up.
in room D8.
I'll have to look on here to see it. It's going to be on the announcements up here as well.
FCA, head to room D8
What's
this time.
SCA?
Hmm?
SCA?
FCA is fellow Christian
Still need a
athletes.
laptop. If you have paid and do not have your laptop yet, head to the multi-purpose room at this time.